Hello friends, I am NEHAL JAIN on behalf of qcfinance. Today I am going to talk something about um, advanced topics in the Matlab. The topics that I am going to cover contains functions overloading, random generation, matrix manipulation, advanced indexing, and all that on you can see on the screen. Now the very first topic is the function overloading. It is a feature found in various programming languages that allows creating several methods within the same name which differ from each other in the type of the input and the output of the function. Now it is simply defined as the ability of one function to perform different tasks. Here is a small example for the function overloading which can be used in the MATLAB software. You can understand the function overloading by this example also. And for the more information about the functions in the MATLAB, you have to just type the help functions command in the MATLAB screen and you can get the details about the function, such as here we have. I have just typed the help functions in the MATLAB and I got the detail about the function. It shows the example also. It is to get the information on a function handle for the polyfunction type. You can you can see this example and get more details about the function, and you can also see the other function property that we can use in the MATLAB, such as function handle, func to structure, structure to function, and many more. Now coming towards the random generation. Now random number generator, that is RNG, is a computational or physical device designed to generate a sequence of numbers or symbols that lack any pattern, that is appear random. Now the MATLAB functions for the random generations are RNG, that is for controlled random number generation, RAND, that's for uniformly distributed pseudo-random numbers, RANDN for normally distributed pseudo-random numbers, RNDI for uniformly distributed pseudo-random integers, RND stream for random number stream, and RND perm, that is for random permutation. You can also get all this command information on the MATLAB help command, such as, now suppose you want more information about the rand command, then you have to just type the help rand command on the command window of the MATLAB and you will get the maximum information about it that you are getting presently on the window. So I have just typed the help rand and it has given me the information about the rand command, and also we can get some examples on how to use it, such as you have to generate values from the uniform distribution on the interval a to b. Then the command for this will be r equal to a plus bracket b minus a into rand 100 comma 1, and there are many more examples on the same that you can study on the MATLAB help. And with this you can also see the other commands that we have already discussed on the MATLAB. Now coming towards the matrix manipulation. On the MATLAB we can easily calculate the factors based on the matrix, such as squaring of the matrix, its determinant, transpose, ones matrix, zero matrix, etc. by giving simple commands that we can see on the screen itself, such as if you want to square a matrix, then you have to simply give a small command, that is a to the power 2, and you will get the answer. For the determinant you have to just write dt of the matrix and the answer will be there. Similarly, for the transpose 1 matrix and 0 matrix, we can get the answers. Here I have tried that example on the MATLAB itself. I have taken a matrix A, that is 1, 2 and 3, 4. Now for finding the square of the matrix A, I have just given a command A to the power 2 and I have got the output as this. And for finding its determinant, I have given the command det of A and I have got the answer. Similarly, you can try many more. Now talking about advanced indexing. Now an array with n dimensions can be indexed using m indices. More generally, the set of indexed tuples determining the result is formed by the Cartesian product of the index vectors, that is ranges or scalars, whatever. Now MATLAB contains functions to help you find desired values within a vector or matrices, such as you have a vector, say vec equal to 53197 are the elements of it, and now if you want to get the minimum value and its index, then you have to simply type a command minval comma minInd equal to min of that matrix and you will get the output. Similarly, it works for the maximum value and its index also. Now if you want to find any indices of the specific value or range, then also you can use a MATLAB, and the command that you have to type will be int equal to find bracket vec equal to the value and int equal to find bracket vec greater than 2 and vector less than 6. These will be the conditions. This you can try in the MATLAB. Now coming towards the inline functions. Now MATLAB has a command that lets you develop an analytical expression of one or more inputs and assign that expression to a variable. The inline command lets you create a function of any number of variables by giving a string containing the function followed by a series of strings denoting the order of the input variables. As example, you can also use that function to return the entire matrices by the following commands. Now the call function. You can call the MATLAB functions using either command syntax or the function syntax as described. Now for the command syntax. A function call in this syntax consists of the function named followed by one or more arguments separated by spaces such as function name argument 1 space argument 2 and till n argument. Now in case of function syntax, function call in this syntax consists of the function name followed by one or more arguments separated by commas and enclosed in parentheses. Example is the function name bracket argument 1 comma argument 2 till n argument and bracket close. This is the difference in the syntax of the command syntax and the function syntax. Now coming towards another topic, that is mesh grids. Suppose mesh grid x and y arrays for 3D plots. We have to write the command x and y equal to mesh grid small x and y bracket. It transforms the domain specified by vectors x and y into arrays capital X and y that can be used for the evaluation of functions of two variables and 3D surface plots. The row of the output array x are copies of the vector small x and the columns of the output array capital Y are copies of the vector small y. Bracket x comma y equal to mesh grid of x is an abbreviation for this function. Now for 3D arrays we use x comma y comma z equal to mesh grid x comma y comma z that produces a 3D arrays that can be used to evaluate functions of three variables and 3D volumetric plots. For example, to evaluate the function x into exponential of x square minus y square over the range x ranges from -2 to 2 and y also from -2 to 2. Here is the function that we use, that is x comma y equal to mesh grid. In the bracket we give the range x, z equal to x into exponential of x square minus y square and surf x comma y comma z. This we can use in the MATLAB command window and operate. Now, mesh grid is like ND grid except that the order of the first two input and output arguments are switched. That is, x comma y comma z equal to mesh grid produces the same result as y comma z x comma z equal to ND grid. Because of this, mesh grid is better suited to problems in Cartesian space, while ND is better suited to ND problems that are not spatially based. Mesh grid is also limited to 2D or 3D. You can also get the more information about the mesh grid by typing the help mesh grid command in the command window of the MATLAB and try on more examples of it. Now coming towards the array slicing. It is an operation that extracts certain elements from an array and packages them as another array, possibly with different number of indices or dimensions and different index ranges. Now the two common examples are extracting a substring from a string of character. So example ELL from hello and extracting a row or column of a rectangular matrix to be used as a vector. Now index of the element to remove equal to C. Now A index of the element to remove equal to null bracket. Now A will be braces 1, 2, 4. Now if you want to remove more elements at the same time, you can do index of the element to remove equal to 1, 3. A of index of the element to remove equal to null. Now A will be 2, 4. Now coming up on the user input. The syntax for it is given as follows and it displays the prompt string on the screen. Wait for the input from the keyboard, evaluates any expressions in the input and returns the value in the evaluation response. Now to evaluate expressions, the input function assess variables in the current workspace. The str response equal to input prompts, s returns the entered text as a MATLAB string without evaluating expression. Cumulative products. Now the syntax for it is say b equal to cum prod of a, b equal to cum prod of a comma dim dimension. Now the first line, that is b equal to cum prod cumulative product of a. It returns the cumulative product along different dimensions of an array. Now if a is a vector, then cumulative product of a returns a vector containing the cumulative product of the elements of a. Now if a is a matrix, then the cumulative product of a returns a matrix the same size as a containing the cumulative product for each column of a. If it is a multidimensional array, then it works on the first non-single tone dimension. Now the second line, that is b equal to cumulative product of a comma m. It returns the cumulative product of elements along the dimensions of a specified by scalar dimension. For example, cumulative product of a comma 1 increments the column index, thus working along the columns of A. Thus cumulative product of A comma 1 and cumulative product of A will return the same thing. Now to increment the row index, use cumulative product of A comma 2. Now let's see the Newton-Raphson's method using MATLAB. The Newton-Raphson solution of two nonlinear algebraic equations. For this we have the following program. Let's see this program on the MATLAB command window itself. Now here is a Newton-Raphson solution of two nonlinear algebraic equations. Now the first step will be the set up the iteration. For this, the code will be error 1 equal to 1.e8 semicolon. Now x of 1 be 0. These are the initial guesses that we have to make. Now x of 2 be 0 and iteration equal to 0. Now the max iteration that can be, let it be 30. Okay. Now we are beginning with the iteration. Okay. For this, the program will be while error 1 is greater than 1 into e 12, iter is equal to iter plus iter will be iter plus 1. Okay, the last second step will become wrong, neglect it. Now the x is equal to xx of 1. Okay. Similarly, the y will be equal to xx of 2. Okay. Now the third step will be calculate the function. Next will be the calculate the functions. For this, we are calculating the function as f of 1 equal to 10x plus 3y, and the function to be the x square and expansion of this that you can see. Now after this, the next step will be calculate the Jacobian, that is calculate the Jacobian. Now we have to calculate the Jacobian. These are the 4 commands for calculating the Jacobian, that is j of 1 comma 1 equal to 10, next is 6y, next 2x, and next is exponential y. After this, we have to solve the linear equations. For it, we have the equation y equal to minus j divided by f transpose. Now after this, move the solution xx of k plus 1 minus xx of k to xs of k plus 1. Okay, now for this the command will be xs equal to xs plus y transform. Now for calculating the norms, the program will be error of 1 equal to square root of this y1 y of 1 square plus y of 2 square. Now error of iteration equal to square root of functions. Now we are having a if loop, and then we have to print that if it not coverage within 3 f iterations, and it max and display it. Now we are checking if error 1 is less than the exponential one, then the result is coming iteration is equal to 0 and error 1 is 3.0150. Now the x value is equal to xs of 1 and y is xs of 2. The function 2 that we are having 10x plus 3y square root 3 and function 2. Now for the result we have to just give the command f, and the output will be the value of f that is 27 and minus 1.9, and xs, the value of xs will be there and the iter value will be there as the output. Now for the plot you have to write, we have semilogy of ii comma air. After giving this command you will get a plot as this is the plot of the command that we have given. Now the next one will be x label. We are giving the name iteration numbers, and see the MATLAB has given us the output with the x label as iteration number. Similarly for the y we can use y label and given the name norm of the functions. After giving this we get the plot named y label as norm of the function. Now for clearing we give the function clear ii and clear error. Thank you friend. Now this was all the MATLAB part that we have to do. So we have saw the Newton Abscess using MATLAB, and the whole program we have tried on the MATLAB screen as well. This is our program that we have done: calculator, the Jacobian, norms, then checked if the error is 1 is less than, and plot the result of that. Thank you friends, have a nice day.